Welcome back, everybody. We are continuing chapter 2.1. This is video B. We're doing linear equations or equations in general right now. And right now, how do we solve an equation? Solving an equation. What we're going to do is take mathematical or take steps to find the solution without guessing and checking. So maybe I'll use a big B. The first rule we're going to really use has like the addition property of equality of equations or equality. If A equals B, then A plus C equals B plus C. What that means is I can add the same value to both sides of an equation. And if it's negative, effectively subtract. Without changing the equality. This is going to look kind of silly, but if I have 1 or 2 equals 2, I can say 2 plus 3 equals 2 plus 3. That's my A, that's my B. The same works if it's a variable. A and B can be variable expressions. The first two we're going to look at real quick are number 12, x plus 4 equals 23. And number 14, y minus 3 equals 0. Now, it's important to note what our overall goal here is. The goal for all of these, goal for solving is isolate the variable. Get it by itself. Like a pack of hyena or a pack of wolves taking down an animal in a herd. Get it by itself. So I want to get x by itself. Right now on number 12, x has 4 more added to it. If you think about it in terms of other things, it kind of makes it a little bit easier. Picture if you were 4 pounds overweight. Your weight, the target weight you want is X, but you're 4 pounds overweight. What would you do to get to the weight you want? You would lose the 4 pounds, right? Lose is like subtraction. So what I'm going to do is I am going to subtract 4 from both sides of the equation. 4 minus 4 is 0, and I just have x over here on the left. 23 minus 4 is 19. So I have x equals 19. I can check it. Does 19 plus 4 equal 23? Yes, 23 equals 23. So x equals 19 is the solution. On this one, we're going to do the opposite effectively here. Let's say you're 3 pounds underweight, which sounds odd, but you're $3 short of what you want to buy. What you got to do, you got to get $3 more. We're going to add 3 to both sides. 0 plus 3 is 3. And the idea is what we're doing is we're getting y, and in this case over here on the left, x by itself. Effectively, we are doing the opposite. Of what is already present. Okay. Do some more in a second. So, what's the other thing we can do? We have the multiplication / division property. If A equals B, then A times C equals B times C. And A divided by C equals B divided by C. Now let's just say C doesn't equal 0 so that we can divide. Let's say C doesn't equal 0, period. Because multiplying by 0 just changes, makes you lose all the initial information. Okay. Let's take a look at some examples that use this information. I'm going to jump down to 38. 4x equals 12. And I'm going to do 48. 7/2 x equals 21. So we have 2 options right now. Here I can, this is 4 times x. So option A, I can divide both sides by 4. Over here, the 4's cancel. 12 divided by 4 is 3. And I get x equals 3. The other option, and I'm going to show it to you so you can actually recognize it for what it is. 4 is like 4 over 1. Rather than dividing by 4, I can divide by 4 or multiply by the reciprocal. Multiply both sides by 1/4. You'll see we get the same thing. We get those cancel. This is 4 times 3. The 4's cancel over here. And I'm left with x equals 3. So you can either divide by the number or multiply by the reciprocal. The reason why I showed that there, where it's like, okay, well, duh, this is a little bit easier to divide. No one likes working with fractions unless they have to. Well, here, I don't want to divide by 7/2. If I do 7/2 x and I divide both sides by 7/2, we did this in the fraction section. This is a complex fraction. This ended up being, those cancel out, but dividing by a fraction is the same thing as multiplying by the reciprocal. 21 is 7 times 3. The 7 cancels, and I get x equals 3 times 2, which is 6. The other option is just doing the reciprocal in the get-go. And you'll see you get to that step a little faster. Same step. But it's just faster. So sometimes multiplying by the reciprocal is easier, because these cancel out. Those cancel out. And we're down to x equals 21 over 1 times 2 over 7. 7 times 3. 7's cancel. 3 times 2 is 6. Again, we can check our work on either of them. This is 7/2 times effectively 6 over 1. This is 42 over 2. And when we divide it, it does equal 21. And you'll notice in some cases, we just got to do a lot more stuff that involves cleaning up. So in some cases, we have both steps. So let's look at some examples where there's both steps. Let's start off with a simpler one, like 56. Ideally, it makes it easier if you do the addition subtraction first when you're trying to get rid of the other stuff. We're trying to isolate x by itself, remember? So I'm going to do the opposite of addition first, which is subtraction. And 13 minus 7 is 6. And then I'm going to divide both sides. Make sure you don't forget the -2. 6 divided by -2 is -3. Does that work? -2 times -3 plus 7 is that 13. -2 times -3 is 6. 6 plus 7 is indeed 13. Okay. Do a little bit harder one. That was 56. Let's go with 62. All right, so here, remember, isolate the variable. Here we got an issue. The variable is on both sides, and we don't want that. We want it only on one side. So we can either A, subtract 5x from both sides, or B, subtract 2x from both sides. Both work. Let's do A first. And you can choose the pattern that you like the best. I will subtract 5x from both sides. 5x minus 5x is 0x. I don't have anything left there, but I do have that -2. 2x minus 5x is -3x, and I still have that 1. Now I'm trying to get x by itself. X is already gathered on one side. So I will start with getting rid of the thing added or subtracted. -2 minus 1 is -3. And then we divide by -3. And we get x equals 1. That cancels. That cancels. Leaving behind a 1 over a 1. What happens if we went with option B? I'll subtract the 2x. And I get 3x minus 2 equals 1. Add 2 to both sides. And finally divide by 3. Or I can multiply by 1/3. I get x equals 1 either way. If I check it, 5 times 1 minus 2, does that equal 2 times 1 plus 1? 5 minus 2, does that equal 2 plus 1? 3 does equal 3. So I would recommend doing whichever's most comfortable for you. A lot of people like having the x's on the left, which is great. In fact, here, that is perfect. Sometimes if we had this backwards, 2x plus 1 equals 5x minus 2, and if I wanted to get my x's on the left, I would have to subtract the 5x to do that, which is fine. We already saw how that works out. But I'll tell you right now, more people make mistakes because of this being negative than anything else. So some people prefer to make it so that the coefficient on the variable ends up positive. Here, if I did it where it ended up positive, I would be moving to the right. Whether or not I like it on the right is irrelevant. As long as it keeps it positive, I'm less likely to make a mistake. Okay. And finally, we'll kick it up a notch one more. Let's go with 68. Here we've got stuff going on. We need to distribute first. Three times x is 3x. 3 times -5 is -15. 12 times x is 12x. And 12 times -4 is 48. I am going to move my x's so that I end up positive. If I move the 12x, I'm going to have a negative because 3 is smaller than 12. So instead, I'm going to move the 3x. And I could do the -15 and the -48, or at the same time, since I know I'm gathering my x's on the left, I can do the opposite of the constants on the right and move them now. 48 minus 15 is 33. We'll divide both sides by 9. 33 is 3 times 11, and 9 is 3 times 3. This simplifies to x equals 11 over 3. Is the check going to be fun? Not really, but it will work. That's what we're checking. Now we can get a common denominator. So if I multiply this by 3 over 3 and multiply this by 3 over 3, I can combine them now. Combine the tops. The 3's cancel here, and I get -4. 12 is 4 times 3. The 3's cancel there. I have 4 times -1 is -4. It does work. Another way to do that check, which has a little like, you can't make the fractions go away. Right away, but we have something that kind of works. Instead of getting a common denominator on the inside and cleaning up the parentheses, distribute. Here the 3's cancel, and I have 11 minus 3 times 5 is 15. 12 is 4 times 3, and over 1, we'll take the 3's, we'll make them cancel. 4 times 11 is 44, minus 12 times 4 is 48. And we get -4 equals -4. So the check gets the same thing either way. Here involves a little bit less fraction work, but it's easy to make mistakes while distributing. So be careful with that. Some things you might run into. So I'm going to do example 1 and example 2 real quick. 4x equals 2 times x, or 4 times x plus 1. And over here, I'm going to do 4x equals 2 times 2x. So if I distribute here, I get 4 times x is 4x. 4 times 1 is 4. And if I subtract 4x from both sides, I get 0 equals 4, which is false. This means there is no solution. So if you follow the right steps and you get a statement that is always false, 0 never equals 4, all the variables have gone away, and it made a false statement, no solution. Here, I subtract 4x from both sides, and I get 0 equals 0. Either here or here, you could have noticed it. The same on both sides. This is always true, which means x is any number. If I stick in 5, if I stick in 3 million, if I stick in -pi, it's going to work. All right. Peace. We got one more thing we're going to do in this section, some word problems with it, and we'll be done with 2.1. Peace.